What I want to talk to you about is we both saw Tyler's presentation, which was talking about the very low level of understanding how the computer in the car will interact with the ultimate self-driving car. And we'll actually also take a look at his videos and see the cool things he's done. But I want to talk about how we're actually going to make this happen in New Jersey. So first thing is we've hit over 100 members on our meetup. So thanks a lot for everyone's effort and help. And so I wanted to just start off with New Jersey's history, not like you guys need to know it or have a history lesson, but why we're doing this in New Jersey. So first of all, we have had some of the most innovative things, such as bubble wrap. If all of your packages from Amazon come with that. The foundation of computer science and all of the internet was built here as well, right? So this is something that we're interested in. And also the first commercially viable light bulb. So this is important because Google's already done a self-driving car. We'll talk about what the problems with that are, but we want to make this something that can actually hit mass market within a reasonable time frame. I also wanted to thank our sponsors before we start. Thanks JuiceTank and Mukesh for sponsoring us and giving us the space and venue, because a lot of this wouldn't have been possible without being at JuiceTank. Secondly, my company is actually sponsoring a lot of this stuff. We're actually having summer internships, and the mission of our company is to create communities of people that solve incredibly difficult problems in an insane time frame. So the self-driving car, I don't think could get any harder. So I think we have a pretty good goal. So the first question is, Google's already done it. Why do you want to do it? Well, Google's vehicles are a little less than awesome. So they've already hit, so the big thing that's problematic is that they have $150,000 of sensors in their car, of which one sensor is $70,000. They've also driven 300,000 miles, which is a lot of distance. I think they may up to be 500,000 miles now, and then supposedly the market is $1 trillion. But the secret of the cars are, the cars have to be driven by a human being down the path that the automated car would go down. And then they would label the stop signs, the street lights, and everything before it's actually driven. And that's because of a lot of the problems in the computer vision and stuff. And actually, we're taking an approach similar to Elon Musk. What he said with self-driving cars is that it should be more of an autopilot, so people can actually turn it on or turn it off based on what their behavior is, rather than go full force and go self-driving. So that's how we're going to take our approach. So we heard both Tyler and we heard Rick talk about what we're trying to do and how we're building it. But where our approach is we're trying to create a virtual world where we can test a lot of the artificial intelligence models. We want to be able to test things in real time and be able to see how things work and operate in a virtual environment first. Similarly, what we're also going to be doing is we're capturing data from the car in real time from the sensors we've attached. So there's a bunch of sensors that we're putting on, such as camera, stereographic camera, Kinect sensors, and I think Krishna here brought a Kinect so we can look at the type of data that's coming off of it. And we want to implement just basic algorithms from Udacity, because we were talking to some people from Princeton yesterday who are going to help us out, who also participated in the DARPA challenge, and they said the algorithms are the easy part. It's getting the right data to test out your algorithms. So we'll be able to do that effectively. And then the last two pieces are to find a car that we can interface with quickly and actually start going on it. I have a 2004 Corolla outside if anyone wants to take a look, and we're going to be attaching the sensors to it originally, but eventually we want to get a smarter car, and I know that Ford and Mercedes and Volkswagen all have really, really good cars we can test. So the goal that we're really going after, right, is in 2014, by the summer, next summer, September 1st, we want a drivable, self-driving car on the highway. Now, this may seem unachievable, but with the people here and the types of problems we're able to solve, this is achievable. Firstly, on the highway, it's a lot easier to drive. Very few decisions have to be made. You don't have to worry about street lights. You don't have to worry about stoplights. You have to worry about staying in your lane, not crashing into a car like Rick's cars did, and being able to change lanes. And those are things that we can achieve in a reasonable amount of time. So the initial steps, the way that we're going to think about this schedule is by the end of the summer, we want a virtual world that we can start getting up and operational, at least hosted on some environment, or someone can take off GitHub and start to actually work on and operate. But we'll get into the different steps right now. So the virtual world, the big thing we want to do is walk through the setup and document the process of setting up the virtual world. So there's process so we can automate that setup so anybody can go on and then run it and then be able to work on it with on their computer, or we can get it hosted on some environment so people can test out models similarly to how they did it very quickly this afternoon. The goal here is to have an easy to set up virtual world, and then the reach goal is to be Udacity's official testing environment for their class. So Udacity, does everyone know that they have a self-driving car course? Has anyone taken it so far?
Just I did.
Okay, great. So the first thing we need everyone to do is be able to take those courses, because otherwise you're not going to have the foundation from a technical point of view. We'll get to the tasks that people can achieve if they're not technical, but right now we're mostly technical. So how we need everyone to take the Udacity courses. And that leads into our artificial intelligence side. So with artificial intelligence, as we talked about, we need to walk everyone through the Udacity course, play in the virtual world with ideal data, but what we want to do is get the sensors connected to the car so we can start getting real world data into the system. And then finally, we want to build infrastructure that can handle the type of data we're working on and operating on as effectively as we can. The goal here is to have vision analysis that can drive highways. Now, is everyone kind of keeping up with where we are right now? Does everyone kind of get what we're trying to do? Okay. All right, so this leads into, if we're trying to collect data from the car, right, we have to put sensors on it. So the types of things that we need to do immediately are research a type of sensors that are adequate. The thing that we know already are the new Connect sensors, amazing. It'll get us a lot more data than we've been able to previously get. Stereographic cameras are also something that we're looking into, but what other types of sensors can actually make sense? And the reason this is important is that this summer, a few of my friends and I were actually thinking about going to San Francisco, LA, Miami, Chicago, and Las Vegas. So we thought we could fly there, but now we have a self-driving car project. We're actually going to drive everywhere. And so we'll be able to get 10,000 miles of data very quickly. We're going to take that data and put it back into the system, and that's something we can then take and to start operating on. The goal here is to get 20,000 miles logged by next spring. So what we need is participation from the community to get some sensors hooked up to your car so that we can start tracking your data and getting that. I know it may be invasive, but it's for the better of humanity. So, and then what we want to do is once we have sensors on the car, we have the virtual world, we have, oh, am I in front of it? Once we get the virtual world, we have the AI models built and we have sensors. What we want to do is be able to get the AI to speak to the car. The biggest challenge that Tyler had and Princeton guys had was that they spent a lot of time integrating with the signals of the car, and that ended up costing a lot of time and eating up a lot of energy. Google ended up having Volkswagen and Lexus basically set up the cars before them, and then they were able to program them easily. That's what we need to achieve. And Ford has already put out the OpenXC, which is amazing with the type of data you can input and output from there. The types of things that you want to talk to a mechanic about, or if you are mechanically inclined, is how can we get drive-by-wire implemented? That's the kind of phrase that people use. The goal here is to have a car that's easily programmed. And then the last concern that we have, not yet, not for until spring of next year, but we need to optimize the software. Like if we're trying, so here's kind of the optimizations we're looking at. If we're traveling at 80 miles an hour, 50 to 80 on a highway setting, that's pretty common. We need to be calculating decisions at 200 milliseconds. 200 milliseconds is about 6 meters or 1.5 car lengths. We could go further than that, but I don't want to crash on a highway. So we like to avoid that as much as possible. And then if you're in a neighborhood or at 20 miles an hour, we have 300 milliseconds, which is about 2.5 meters or half a car distance. But the problem here is that there's more things to operate on. There's stoplights, street lights, pedestrians, animals. There's a lot more types of things that you have to be aware of. So that way we have more time, but it's 100 milliseconds. And we have to be at a 30 frames per second processing. So now we know what kind of tasks we have from a technical point of view. I wanted to get into the types of groups that we need to have happen and to types of teams that we need to build to make this actually effective. So we have a core team that needs to be dedicated, and that's myself and a few of the guys already. But if you guys are looking to dedicate at least the next part of the summer, if you have nothing else to do, this is probably the best thing to do. So we need a lot of people dedicating their time to building out things that are going to be common across the community. Logos, the name of the project, self-driving vehicle, as awesome as it sounds, is probably not the best name to choose, so we can talk about it as a project. And the other thing is just we need to be able to maintain timelines. That's not going to be effective if everyone in the community is assuming everyone in the community is going to be doing something. Then we've gotten a lot of emphasis on the software teams that are going to be working on the virtual world and the artificial intelligence. That we've honed in on like the entire presentation. And then there's the engineering side, which Tyler has been very, very active on. And then the software side, Rick's been very, very active on. So we have those two teams pretty much, they're in pretty solid hands. Now, where the other non-technical side of things comes in is in art, in terms of documentation, in terms of taking pictures, in terms of videotaping. Like, these guys are doing a great job in live streaming this whole thing. So we need more types of efforts here, and the whole purpose here is to build a logo, a common theme, a common understanding of where the future is going, and then be able to visualize that for everyone so that we can get it done really quickly. I just wanted to talk about some things legally. If we're going to do this as a community, I want to make sure everyone's putting their work in and they're protected. If you don't know what these licenses are, it doesn't really matter. Just look it up later, but I just wanted to put it out there. Data is going to be under the open database license, which allows it to be public domain without getting yourself in weird places. Art, video, and photos are going to be under Creative Commons. Documentation is going to be under Creative Commons, and actually, if you look at this documentation, there's some really cool things where there's actual pictures and then diagrams, and then a brief description about what's going on. And then finally, the code is going to be under BSD. It doesn't matter if you don't know what these are, and then if we come up with patents, what we want to do is make sure that the community can use them on a non-commercial basis so that we can start doing things with it. But with that said, what I want everyone to do is, if you know you want to be involved in this project in some capacity, or you want to do something here, sign up. All of us have sign-up sheets that we can get you signed up, get your email, your name, and your phone number, and then get you tied up very quickly. And as long as you know what you want to do, we'll be able to do it very quickly. Even if you don't, we'll be able to get you somewhere, and then you'll be able to get effective very quickly. So that's what we're really excited about doing here. So it would be awesome. And then I know Rick has a demo in the back, so you can check out what's going on over there as well. And then we'll see if we can get Tyler's video. But I think that this is something we're all excited about.